Okay, well, today we're going to talk about views, user-defined functions, and store procedures in SQL Server. So for those of you who already kind of work very heavily with SQL Server, that's not going to be a very interesting session, but for those who don't use them a lot, it'll be quite a useful piece of knowledge. Okay, so we'll start off with the views. Do you remember when we were going through all the objects that we have available in SQL Server? We have tables, which are our relations, and tables store our information. View, it's another type of object. And does anybody know what the view does? What is it for? Where do we use it?
Essentially, it's querying itself, isn't it?
That's right. Basically, a view, all it does is just stores your SQL in a manner that can be accessed. So the advantages of using a view is really, primarily used to restrict access to certain piece of data on the server for a specific user. So what we can do is we can create a view, then assign a permission to a user to use that view only for selecting purposes. View can only be used for selecting stuff out of the relations that you specified in there, and they can only see the columns and the information that we specified in view. We can also restrict the user to actually see what the view, what code the view actually contains. So all they can do is they can just use that view as if it's a table, and they can reference it, they can join to it, etc. So for the coding purposes, the view becomes as if it's an object, but in fact it's a compiled code effectively. So it's got its own execution plan and all that kind of stuff. So we're going to look at it, and we're going to basically prepare what's going to happen to our execution plan when to our execution plan when we actually run a view. Okay, so for example, in Linux, we do have some views in use. I don't know if you've kind of seen, met them. We don't tend to use them a lot because they're not very well. You can optimize a view to be very robust, but then if it's overused, then generally, basically, we don't tend to use them a lot. There's a good reason. This could be a performance leak in the view that you don't know about. It's quite a good way also to implement a better coding practices. Like, for example, you just write quite a heavy select, for example, in the most efficient way, and save it as a view and refer to it all the time from different joins. So that could be quite useful. But again, we don't use them a lot for the reason of performance leaks, really. Okay. So what I'm going to do is I'm going to write a view. Does anybody remember what we did last time? No, it was 2 weeks ago, but sorry?
Aggregation?
We did do aggregations, yeah. Well, we ended up with quite a big query. We ended up with a query with several joins, and we did some aggregation. We also did some subqueries, all that kind of stuff. So if you think about the view, it's almost like a subquery in our select. What I'm going to do, I'm going to go and jump to my select that we previously had in that we did last time, and it looked something like this. Okay, we have this as a with statement at the top of the query, but here we can't use with within the view. So if we want to reference it as a subtable, we actually have to use it as a subquery. Sorry about that. Okay, so that's the query, and what I want to do is I want to basically compile this query into the view and just reference it by as if it's a table. So this is a select, and all I need to do is effectively just basically go and create view, and then I'm going to give it a name. I'm going to give my name as and specify SQL statement. Okay, there's one restrictions in the, there's lots of different restrictions in the view. We can't obviously do a procedural code TSQL in the view, so we can't create a temp table and put something in that temp table, etc. We can't order by, of course, because it's almost like a subquery, and we can't declare any variables, anything like this. So basically treat this code as if it's a subquery of the normal query. Okay, so execute this, and now we will have in our view objects, we will have something like, yes, there you go, product inventory sales. As you will notice, there is a schema as well. Start introducing the schema now, because the next lesson, after we've done all this, after we looked at views and user-defined functions and stored procedures, we're going to look at schemas and how we can control the permissions in the database and how we can secure the database and basically delegate each section of the database to a specific user, specific user set or user groups, etc. Okay, so when we just create a view without specifying any specific schema at the beginning, it becomes DBO. What's DBO stands for? You know, why? Sorry? Yeah, it's database owner, basically. So every object has to sort of reside with some sort of schema. By default, it resides in DBO schema, which means that anybody who is an owner of the database, or who's got data read access, data write access, can access this object fully. So they can open it, they can look at the code within that object, they can look at the data within that object, etc. They haven't got any restrictions to it. So you can see here, for example, there are some views that have been created in this database by default, and they've got different schema. Right? So we can refer to this view now by saying something like this. So we created this view, and now we can do this. Select from DBO, and then the view name. So what's happening is it's actually going to basically execute the code that we inserted before. So let's come back to this. Run this statement with the execution plan. That's our execution plan, okay? And if we now do this, so we're just going to select out of this view with an execution plan. It's exactly the same. So it uses this basically as if it's a as if this is a subquery. So it's almost the same as doing this. Exactly the same. All right. So we can also reference, obviously, because it's now became an object in our database. It's got code within it, SQL. We can reference this in our joins as well. So, for example, we can write a query that does something like this. We select it from product, and then we left out a join to product inventory sales. Left out a join because we want to select all the products, whether they have a sale or not, and run this. And now basically if you look at our execution plan, you can see that our execution plan has now changed slightly, and it's now basically renders this execution plan as if this was a subquery, or basically as if this was a recompiled. Well, basically it treats this as a separate SQL statement. In fact, it doesn't treat this as a subquery now. So she treats this as part of this SQL statement itself. So it will look at, there's nothing really to see to demonstrate this, but basically it didn't treat this specifically as if this is a subquery. So it didn't execute this execution plan first, effectively, and then took the output of that and then joined it to a product table, etc. It actually decompiled everything, well, decompiled it, trying to estimate the best way to execute this query based on all the joins within this query, as well as joining to a product query table. Well, okay, I think that's about it about the views. Really, they're quite simple. It's really easy to understand. There's one additional thing that I want to mention about the views. We can have static views. So what we can do is we can create a view that because basically the views don't contain any data. They're simply a SQL statement that refers to a table where we actually get the data from. But what we can do in SQL, so we can create the views that become static tables. I think they call static views. So we compile the view, and all the data that got selected during that view will be put in the table. So it will be actually stored as data. What's the benefit of that? What do you think?
Gives you a history of the values in that table. So presumably that's a snapshot of one instance, whereas there's values from the original table might change.
Not really, because the next time you run that view, the data will be overwritten with the newest selection. Exactly, because all the data is now pre-calculated. So if you're doing something like a report of some sort on a daily basis, something like this. So first thing you can do, I mean, because view is quite limited in terms of what sort of data you can process, we can only do select, so we can't look at the source tables and see have they changed much since the last time we executed it. But what we can do is, for example, we can have some kind of trigger that recompiles a view. So every time the data changes, we can literally recompile that view, and this is like a commonly used dashboard data. So instead of recalculating all the data again, we can effectively save it as if it's a table in a database. So when we next need that data, all it is that we're doing, we're just reading directly out of that database, out of that table. So they're called static views. We're going to talk about them later, and we're going to talk about different ways of doing the same thing as well, because I know for some of you that would be quite useful when we need to do some queries for the customers that doing a lot of calculations, computations. We don't want to overload the server, so there are ways of reducing that load with those static tables, although that does come with a downside that we don't get the latest data. We only get what we actually compiled at that time. Okay, the next thing I wanted to talk about is user-defined functions. Okay, what is a function in the first place? Anybody tell me?
Some kind of calculation that it's value.
Yeah, simple as that. So, for example, let's declare a value, declare a variable. I'll become varchar 25 and give it a name. Well, value better, for example. Hey, what I can do is I can calculate its length of that variable. Okay, 5. Length is a SQL function. Okay, we give it a value. Well, we give it a variable. Then it does something with it. Basically, goes through and counts up all the number of characters and returns you a value. So that's the basic idea of a function. There are a lot of built-in functions within SQL Server, but what we can also do, we can introduce our own. So we can write things. They're very useful if we need to, let's say, split a string, comment delimited string into a table. If we want to calculate the day, the week number in a different way, maybe we want to do some calculation with date. For example, here's another example. So this is a date time, and it contains the date, the time as well. What I want to, for example, I can write a function to strip out the time and just return the date, so that becomes the beginning of the day. Or for example, I could have a function. We do actually in Linux, we have functions, user-defined functions that calculate the beginning of the week as well. So it looks at the current date, then this, deducts the number of days, the weekday number of that day. That basically gives you the beginning of the week, and so on. So that's what primarily functions are used for. And let's actually gonna have a look at write one. Okay, so what I want to do with this function, first of all, we start off writing the functions, create function, give it a name, give it all the parameters that we want to accept into that function, returns, and then what type value it returns. So in our case, we return integer. And in this, I'm just going to do a very hacky code where I'm going to return a color code based on the first letter of the color, and literally going to hard code all the color names into these functions. So for example, when the color is null, when we provide it null, it will return 0. When the color begins with letter B, so it's blue, black, purple, and that's all the colors I know. We return 1. When it's green or gray, return 2. And then for everything else, we return 99. Okay, and then in the end, we have a return function statement that actually returns the data. So create this function, and now we can actually run it the same as we did with len. And if I put something like better in there, if I run it, it tells me it doesn't recognize it. So we created a function, and I'm using the same name of function, the color code. See, just I'm actually going to go and copy and paste it. And it doesn't recognize that function. It says it's not recognized as a built-in function. What's wrong with it?
You need to give it a prefix because it's specific to the database as opposed to it being a built-in function like then.
What kind of prefix I need to give it?
Something that identifies it's within that actual database.
So have a look. Programmability functions, and we've got scalar values, and we've got table functions as well. So because this function returns only one value, it becomes a scalar function, meaning that it returns only one value out. We can also have functions that return tables, so they're going to be placed into different things, different sets. So it's here. What do I need to prefix it with? Yeah. The tables, we don't need to prefix them with DBO most of the time, unless they have a different schema. For views, exactly the same. We don't need to prefix them. For store procedures, we don't need to prefix them with DBO because it's a different schema. But for functions, we do, because there are built-in functions that are on a different
Level.
Something like that. Okay, so now we can run it, and it returns 99 because that color is not known. If I put black, it returns 1, and if I give it a value of null, it returns 0. Okay, so now we can use those functions in our SQL queries as well. This function, SQL query. So what I'm going to do here is I'm just going to run the same query that I was running before, but instead of returning the color there, I'm going to put it through our functions, the color code function. And as a parameter, I will supply the value of the color into that function. So it will then return, basically for every single row, it will run that function, and it will return a value. Cool. And again, if we look at the execution plan, we will see some scalar computation in there. So we'll look where it appears. Compute scalar. I think it's here. No, I can't even see it in the execution plan. Must be there. Script ID. I wonder if it even appears on the execution plan as a function that run. From the output list, I don't see it being anything to do with the code. This one. Nope. That actually selects from product code, and I would expect it to be this one, for the reason that it's not actually part of our selection. It's done right before we actually output the data. So we're not using this in any of the where clauses or any of the joins, except any of that. It's literally happening when we return the data. That's what I would expect it to be there. But to be honest, from the output list, I don't see that's happening. And maybe this is an output list. Output list doesn't really refer to it. Okay.
And it's got the expression, isn't it? 1008.
That's name, color code. Yeah. No, I'm going to have a product ID. Yeah, returning, then a name, then expression 1008. Where's 1008 happening? What about there? Output list 1008, 1009. Must be this one. Hell knows. I don't know.
You give it a name, does that help?
Give it a name as in.
Well, declare it, although I suppose it's just called product code. It's just interesting that name was in there, product ID was in there, and since it got the color code, it didn't give it. It's only put the expression 1008.
Yeah, but because this is a calculated value. So, for example, the other two, as you see, expression 1010 and 11 are also calculated values because they actually happen in the product sales. And this one is actually related to calculating product sales, the aggregation of the product sales. So it's perceived with a hash match aggregation and so on. So I would still expect it to be that. In fact, let's check it. Let's go and remove this, rerun it, and see it. We'll go to computer scalar. This is our calculated value of the aggregate, and I think that was that one, yeah. So it does appear somewhere, but it's not very clear that this is actually a function. Anyhow, let's go further. So as I've mentioned, we can have a function that returns an integer. We can also have functions that return tables. The reason for using a table a function that returns a table, I in my career haven't found a single valid case for doing that so far, but it is there, and it can be quite useful, I suppose. But most of the time, it would be useful if you run in it as if you're referring to this function as a view sometimes. So in some cases you want to basically, let me go through it first and then we'll kind of think about where we can actually use this. So here's a simple function that returns a table. So we write it pretty much exactly the same. Create function, then it takes a parameter or color, and then it returns a table. So here what I want to do is I want to return a product sales based on the parameter color. So for products of a specific color, I want to return their sales. Okay, and it returns a selection of some sort where I use the color as a clause, as a predicate for our selection. Okay, I'm going to run this, and now I can do this. Select from product sales, and then we specify black. Will it run? Will it run? In video. Okay, so use it as if it's a table, as if it's a view, and I can give it a specific parameter. There you go. Function. So, and we can also use this as an object. So we can write something like this. Select from product. We can use the function color code, and then we can also left out a join to it as if it's a table with a parameter black. And run that. Okay. And that will basically be treated as if it's a view with specific parameters. Okay, so any ideas where would that be useful in your in your opinion?
Essentially, it's so you can build a view, but actually then pass in a set of parameters for it. That's the only part I can't.
But I can build a view that return all those columns in it, for example, that I want. And then I can fill them out with the where clause. Can I not?
Can you pass a parameter into a view?
No, you can't, but you don't need to in that case.
But the only advantage in passing a parameter in means you can have one view. But instead of, if I wanted one for black and I wanted one for blue and I wanted one for green, would I therefore have to have three views?
No.
Now I can have one function in return.
Yeah.
Yes. What will you call them? Yeah. Okay.
So you could do that. But what if you imagine what if you didn't want to return a color to the user? For example, you wanted to restrict access to the data to the user. For example, it wasn't, imagine a color. We don't want a user to see all the different colors of our products in a database. So we want to give that user a functionality to select the specific colors that they can select. I know it sounds a bit weird when we talk about colors, but we talk about some other type of data. For example, a region where a sales rep can do something, whatever we want to talk about. Basically that a user is allocated a portion of data in their database.
Yeah, and certain categories within.
Exactly. So that view, we can actually create it as a function instead, where they pass in their territory code, for example, their category, and we only give them that data back, nothing else. So if we use it as a view, we would have to return that category to them, and they would actually then take all of that data and filter out everything they don't need. But we don't want to give them everything they need. We only want to give them what they want. So what they can see, basically. So in that case, the table function can be very useful because we can, within the function itself, we can define what sort of data they're going to get back. We can also do it in a very, very smart way because we can then look at the user name that actually executes that function, link them to their permission straight away in the table, the permission table and only give them what they can see straight away in the function without even. Yeah. So that's one useful case for a function for one of restricting the data that gets used. Also, sometimes it's necessary to pass in a parameter of some calculated value in the function, like I've done here, which we can't do with a view. Well, we can, but this will be very crude. And because we then have to join to that view, results might be a bit weird. It's a very bad idea to use views in the table views or anything that basically, if a function is doing some sort of select, it's a good idea to use it, but as if it's a table or as if it's a view. In your joins or in your selects, it's a really bad idea to use them as aggregate values up here, for example. In fact, for example, calculating quantity, I could write a function that calculates a quantity for every single product. Do you know what I mean? No, probably not. I'm not explaining it well. Right, so for example, if I wanted to, you remember if we go all the way back to this view here, right? Where we created the product inventory view, we calculated the quantity, no, we calculated the sales with the subquery here, right? Remember, if we go back a couple of lessons beforehand, we had the same calculation happening as a subquery in a select statement itself. So instead of actually selecting quantity, we were doing something like this: select sum order quantity from there where product ID equals the product ID. Okay. That'll be the same kind of thing, right? So I could write exactly the same. I mean, I could write this as a function. Can I not? I can write this as a function that basically takes one parameter, product ID, that does a select on sales order details and returns you this the number of items sold. Actually. So that'll be one case where I could do this. But remember, if we go back a couple of lessons to have looked at this, we said this is a retarded way of doing things, or it might not be. In some circumstances, that might be even better. So if we look at the execution plan, what are we going to see there? Well, this execution plan, for example, doesn't. In theory, that should have basically looped around for every single record. It should have gone to sales order data. But because SQL Server is a little smarter than that, it actually decided to pre-calculate all the data in sales order for all the products. Did it? I don't see any nested loops, so it must have done it. But without any hints to this query, for example, that's what I would expect SQL Server to do. It would have to, for every single record, it would go to sales order detail table, and for every single product, we recalculate the value again. So obviously, we have a couple of million rows. It would do a couple of million times. So that's obviously very heavy on the computation. And remember, what's the most what's the most expensive operation you can do in SQL Server is no, because nested loop is read function. It's IO heavy. Sorting is expensive, but not as expensive as aggregation, sum or count. Okay, so if we're doing the whole sum in one big chunk, the amount of CPU we consume is going to be a lot less. and it actually spans from the architecture of how how the processors work themselves. They have a certain number of quantums that processor can run. When we're doing a calculation in one big chunk, the processor basically can run calculating these values in the longer term without doing so-called context switching. When we're doing something like nested loop, where we have to go get the data, return to the function, run it again, so-called context switching happening, which is a different thing. We're going to talk about the context switching in SQL Server in the advanced stuff. Anyway, so move on. That's pretty much all I wanted to basically mention about the functions. They can be quite useful. They can be very dangerous. From a performance point of view, you can write a function that will literally bring your server to a crawl in a manner of, you would think that what's wrong with that? It's okay, but if you actually find out that all the SQL Server is doing is just running that function most of the time. Okay, so you have to be quite careful now. All right, final bit that I wanted to talk today about specifically stored procedures. So we actually go by the Microsoft manual. Stored procedure is a collection of TSQL statements that all compiled in a single program effectively. But if we go by a normal understanding people can actually understand, it basically becomes like a method within your SQL Server database. Or to go even further up the chain, then it becomes almost like a program that you can run. It's pre-compiled, so the execution plan is known, and the SQL Server knows exactly how to execute that query. And it doesn't need to convert all the SQL that you've written into something that SQL Server database engine can understand, because once you compile the stored procedure, all of that already happened. So it translated all your SQL into something that SQL Server can understand. Every time you run it, it's much faster. Okay, so that's major benefit of using a stored procedure in the normal circumstances. It's just faster. Secondly, it's very code efficient because you can write a stored procedure once and you can reuse it in many places. Also, you contain the code in one place. If there's any changes that you need to make, so you make it in stored procedure and it propagates everywhere else. Unlike view or function, stored procedure can do anything. So you can insert data, you can update data, you can create temp tables, hell now. You can actually delete files on the server from within the stored procedure. You can connect the separate assemblies, you can talk to the web service, you can send emails and things like that. So stored procedure is basically a program within SQL Server. Primarily, we use stored procedures to work with the data in the most efficient way. So in Linux, we use stored procedures a lot, and quite frankly, everybody's using stored procedures a lot. They give you the same flexibility from a security perspective, where you can limit the users to only run specific stored procedures. So, for example, you can create a user that can just insert data in certain tables and get the data out of different tables. And again, you can, within the stored procedure itself, you can look at the ID of the user and then give them access to the data that they need only. Okay. Right. Let's have a look at some stored procedures and how we can write them. In the previous lesson, we've done so-called procedural code. You know what procedural code is in TSQL? Yeah, it's your good old Visual Basic style of writing things. One thing happen after another. You can even do go-to things, but you can write really good spaghetti code and get everybody confused as hell. Okay, so this is the procedural code that we've written in the previous lesson. And what it's doing is basically, I'm just going to declare this value as well. And that's going to be value. Yeah. So just to reiterate what was happening in the previous lesson is we created a temp table. It's a temp table. Remember? Yeah, where is it stored, the temp table, when created? What is it?
It's just stored in memory, it's stored as part of the database itself.
Yeah, and it's basically a table that is that is alive while we have the connection. So while we run in this query, well, we have a session basically. When we start running a query, a session gets created. So all the code gets compiled and everything is happening within the context of that um, session. In the TSQL, we can separate sessions by a go statement, like this. So for example, if I try to run this now, it's not going to work because I terminated the session here, and our product selection table was declared in this session. So everything that is happening within one basically chunk is a session, and we declare a temp table within the session itself, and that temp table could be stored in memory if we have enough memory on the server to do that, or it could be dumped into a virtual memory, which is a file system. Most of the time it ends up there anyway, but if the server has got plenty of memory, it will just actually all be happening in memory. Okay, so here we're going to create a product selection table. We're going to stick some products into that table, product IDs of a specific color, and then instead of doing a subquery, we're going to do a clever calculation. I don't know whether it's clever, but it's basically number of price revisions and average list price. We're going to update that temp table that we declared, this product selection table, with those values. Then we're going to add, with another update statement, we're going to add all the sales, a number of orders that have been placed, and then finally we can do the final selection. Do you remember the advantage of doing things like this? We could just do everything in one big statement here. Could we not? We could create a view or function that did this and basically reference it within the final select. But what's the benefit of doing it like that? Yeah, but when I'm writing query that will be executed a lot of the time, I'll just have a temporary. Okay, do I really care whether it's really easy to look at for Chris when I write queries?
No, you will be when you want to come back and check it out today.
Yeah, but still, for example, if it's a performance drag, doing it this way, will I really? No, I don't. I will write it in the most efficient way for the server. That's what I would normally do, for example. The benefit of doing this, for example, is first of all to break it down into multiple chunks. Yes, readability is quite an important part of it. Debugging is quite an important part of it because I can then break it there and I can have a look what's actually been inserted into my table before proceeding further down. So it's a very good way of debugging things. But also what it gives me, when SQL Server runs this, it will run every single part separately because they are physically separated. So while it's running this, it's done it, and then if there's another query pending, it can switch to another query to serve another user and then continue with this one. So if we do a very long sort of query that puts a lot of data together, then every single statement will be run separately, and we can serve other users on that server at the same time. Okay, of course, SQL Server is multi-threaded. Yes, yes, yes. Obviously, even if we run a big query in one big go, there will be another threads created to serve other users and blah blah blah. But that will create so-called context switching all the time, right? Even within this statement, the context switching will still be happening, but here we can actually control. For example, we can pause it. We can basically say wait for 5 minutes or 5 seconds before you proceed to the next statement, and it will put that thread to sleep, etc. So we've got a lot more control over this query. It only applies to when we're doing something really heavy. In some circumstances, for the sake of getting the right data, it's a good idea to break them down because it just makes more sense. And a lot of the times when I write very big queries, like very heavy computations, I always break them down into smaller parts. And then when I need to achieve the performance, I put them all back together. And in some circumstances, you will actually see in the store procedures that I've written ages ago in Linworks. For example, you'll see one big query at the end of the store procedure, and then you'll see exactly the same thing, the broken down bit that actually does it, bit by bit at the top, all commented out. So this is the thing that I compiled it from. Okay, so right, so this query we can run now, and it will return something. And basically, what I want to do is create a program out of it, basically. So what I'm doing is this. Okay. It's a good idea when you write stored procedures is to literally write them as normal SQL, or well, TSQL, with all the parameters defined at the top like this. When you're ready, just replace all the top parameters with create procedure, or if you modify the stored procedure, alter procedure, then the name of the procedure, all the parameters in there, as, and then your code, actually. We can give them a default values as well. So for example, if we haven't specified any value when we run this stored procedure, black would be our default. Okay, and when you add in, if you take in a stored procedure and you need to add another parameter to it, you must specify a default value. Whether it's going to be null, whether it's going to be some static value, but you must specify something.
But if you've already set a default value for one.
No. If you have a stored procedure, for example, imagine I went and said, you know what, I'm going to go and modify the stored procedure here since somebody wrote. And for my code, I need another parameter. That'll be color. Okay? If I just rerun it like now, for example, then all the code that uses the stored procedure will fail. For example, within C#, when we use this stored procedure, it will fail because we haven't specified a color value for the stored procedure. We haven't specified that parameter. So when we add any columns, first of all, we never remove any parameters from already existing stored procedures unless you wrote it, and 2 minutes later you realize that doesn't need to be there. If you modify that something already exists, you never change any of the parameters, you never remove them, you can only add them. And when you add them, you always have to specify something in that parameter default value, because if you don't do that, exactly. I'm looking at Ethan right now. There's a stare. You get it? Okay, so you always have to do this when you modify it. Alright, so it's going to run this. Now it basically created another stored procedure in our system. There you go. Prefix DBO, because it was created without specifying any specific schema, and now we can basically use this stored procedure. And we use this like that. Exec stored procedure, and then we specify a parameter. We can give them specific names so that they clearly defined like that. There you go. Or change its value. Or because we specify a default value, I can specify nothing, and black would be our default value in there. Okay. So from the execution plan perspective, what's happening? Everything is precompiled, blah blah blah, but it still uses the execution plan. The downside of having a precompiled stored procedure is that when you were developing, or for example, when the database is small, It's got some statistics on it, saying like there's like 500 rows in this table, 500 rows in that table, or 1,000 rows in that table. So we should do select like that, for example. That's what SQL Server is doing effectively. Estimates that execution plan before it runs it, based on statistics of the table, based where the indexes are, indices. Indices? Yeah, it's indices. I think it's the correct way. Indices. Indices. And basically that estimates that's how that store procedure will be run. But then when you start dumping a lot of data into these tables, when a lot of things get inserted, then that's not that's not necessarily that's how the store procedure should run. Normally SQL Server will update so-called statistic, and then we will try to recalculate that store procedure when it's when it starts up the resources, it's not going to do it. So the execution plan for a store procedure can remain based on the previous data. And that's when you need to run either dbcc functions to update statistics, or there are some internal SQL Server methods that say dump all the statistics for all the store procedures and recalculate them every time we run. Next time we run that query.
So how does that work for our database? In the sense of we set up a brand new customer with an empty database which has got versions of our store procedures, and as their database grows, do those store procedures get recompiled, or have we got efficient compiled versions that we install from the start?
We just basically install everything with the empty database.
Yeah.
And in many cases, for example, the execution file will be carried from a dev database with all the crap that we've inserted in there. So there will be already optimized for. That's why we've got so much crap in our dev database, and so much irrelevant and stupid crap in there, so that we can have the most the execution plan that is most relevant to a lot of crap actually when we start off. But then when we run the maintenance every day on the database, for some tables we recalculate statistics which will cause the store procedures, all the related store procedures, to recalculate their update the execution plan. And I think we're now even adding a hinted statistics update. So we say, for example, use this in this table, and then this one got DBA actually, because you can figure that out. But you can say, for this store procedure, use this in this table, but ignore that one, for example. Every day when we run the maintenance plan, we're doing these things for our customers to make those executions faster and more efficient and most relevant to their database. Okay, so obviously we can't use store procedures. In our case here, for example, where is our store procedure? Okay, all it does is basically select some data out. So we can use the store procedure in our C# code as if it's a select statement, basically, as if it's a query, and it will literally return this. Okay, we can do it so it returns multiple results. That's not a problem. I've done this heresy there, but that's for demonstration purposes only. Never do that. Okay, and when we run this, we're going to get 2 result sets, and from C#, when we use this query, we can actually return 2 different sets at the same time. But we can put them in the data set, or we can actually refer to first set and then the second set, so on, when we convert them into classes or whatever we do with that data. Okay, so this store procedure in this case only returns some data. But what we can also do, we can insert the data into tables. We can get sort of several selects to look up some values. For example, we can have store procedure that accepts location as a name, and we can look up the name of that ID of that location by name. If it doesn't exist, we can insert it into the location table, and so on, basically. So store procedures can do a lot. That's why we use them so much, not only for the performance sake. And because they are inserting data and doing so all different things like sending emails, we can't use them as views basically. So we can't, we can't do something like that. Oh, it is. Even with the DBO prefix. That would be awesome if we could do this, but we can't. Because store procedure is a program effectively. And because it returns multiple undefined results in it as well. The reason for why we can't use store procedures for selecting data in our joins or subselects, etc., is because the return out of those store procedures is variable. For example, I can have something like this. If it's get date, for example, I don't know, day is Monday, then I return this. And if it's not, then I return something else. Okay, let's change that to 2. Today is Tuesday, right? What day is today? Sorry, 22nd, yes. I don't know. Yeah, so basically because the output of the store procedure could be variable, we don't know exactly what's going to be returned, can't use them in and because they are basically just programs. I mean, many different limitations in that. We can do, I mean, you will find in on the internet, in a great expanse of stupid stuff, you will find references to where you can actually output the, well, you can use the data returned out of store procedure in your queries. For example, there's one way of doing this. You can create a temp table and then execute store procedure and output the result of that store procedure into a temp table. Use that temp table in your query. Never do that. It's daft beyond the point. It becomes very unstable because if somebody then adds another column as an output into that store procedure output result, then your code will break and you will never know where it actually broke. It's just going to say that number of inserted values doesn't correspond to number of blah blah blah, this kind of stuff. So don't do that. Write a view, write a function, write a subquery, but don't get the output of the store procedure just as is, or modify the store procedure so that the bit that you want to return, that you want to use within your query saves it as a static view, or is created as a view, or created as a function or something, and use that function within your store procedures to get that data, etc. So don't get the output and use it in your queries out of the store procedures. They are used for different purposes. Okay, that's it. Any questions?